And one of the things we're going to be focusing on here is electrical charge. Do you guys know the types of electrical charge? There's negative. Yep. Negative, positive, and neutral. So if I tell you that you have an atom, and if you're still on your phone, you need to put your phone away, and you need to be on page 93 of your white book. Page 93. So if I tell you you have an atom, atoms are neutral, okay? And you'll see there's no charge written up here, it's just blank, yeah? And that's as opposed to an ion, where you can see there is a charge written at the top. Sometimes it'll be written inside, like maybe instead of writing it outside, I might write Mg, and I might write the 2 plus inside the little circle. But the deal is that an ion has a charge, and an atom does not have a charge. So atoms are neutral. Just by looking at this picture of a molecule, what could you say about the charge of a molecule? Tell your partner what you think. Does a molecule have a charge? Or does it not have a charge? I should hear discussion between you and the people near you. Does a molecule have a charge, or does a molecule not have a charge? Just taking a look at that picture, what do you think? What do you guys think? Yes, no? No, it does not. You see, there's no plus or minus. So molecules are neutral. Atoms are neutral. Ions have a charge. Now the last one is a little bit tricky. It's called a formula unit. And I would like you to take a good look at that. We have a plus here, that means +1. We have a minus here, that means -1. And I would like you to tell your partner, what do you think about that formula unit? Does it have a charge, or is it neutral? What do you guys think? Neutral. Why is it neutral? Because the positive and the negative balance. When you have the same amount of positive as negative, you end up with a neutral charge. So although it is made of charged particles, the positive charge is equal to the negative Therefore, overall, it is neutral. thinking back to Unit 1. What kind of a substance is NaCl? See if you can remember that. Tell your partner, what type of a substance is NaCl? Oh, I heard a couple of correct answers out there. Anyone want to give it a try? Be brave, be an intellectual risk taker. Yes. No, but in fact, salt, all ionic what? Compounds are salts. Yes. So it is an ionic compound. It's a compound. How can we tell that it's a compound? We have two different elements bonded together. And we know that it is an ionic compound for two reasons. Pardon me? No, I think you're right. One is a metal and one is a non-metal. So we know that it is an ionic compound because we have a metal plus a non-metal. How else could you guess, if you didn't know that it was a metal and a non-metal, from this picture, how could you guess that it is an ionic compound? Well, let's go back and take a look at our ions. What do you see about the ions? They have a positive charge or a negative charge. What do you notice about sodium and chloride? They have a positive charge and a negative charge. This is an ionic compound because it is made out of, what's it made of? Ions. Oh, imagine that. An ionic compound is made out of ions. Shocking, I know. So we have this formula unit, which is actually a little bit unreal. If you have an ionic compound, what structure does it actually make? An ionic compound actually makes a crystal lattice. How likely do you think it is in this world where, you know, you've got some sodium and some chloride sitting around, how likely do you think it is that only two of them are get together and form a little, you know, dyad, two of them holding hands, without anybody else being involved, any other atoms or ions? It's very unlikely. So a formula unit is something that we use in chemistry because we're like 1 unit of sodium chloride. If I could just take one of those and one of those, that's a formula unit. It's almost like a molecule, but for an ionic compound. So a formula unit Formula unit is like a molecule, but it is for an ionic compound. Now let's pop back to our molecule here. What type of a substance is this molecule? You remember we went over to NaCl and we were like, what type of a substance is NaCl? And you told me it was an ionic compound. It is also a salt, because all ionic compounds are salts. So what kind of a substance is this molecule here? Sorry? It is water. What type of a substance is water? Chat with your partner, have a little discussion about it. What type of a substance is water? H2O, what have we got? Anyone want to give it a try? Yes, it is a compound. Yes, brilliant. And I know you've been waiting to say that. I could see it earlier. Okay, this is a compound. How do we know that it is a compound? It has different elements bonded together. Now this is made of oxygen and hydrogen. What types of elements are oxygen and hydrogen? They are both nonmetals. So we have a nonmetal and a nonmetal. So these are all nonmetals. Do you remember what we call a compound that is made of all non-metals? What type of compound is it? Yes? It is a covalent compound. Yes, it's not ionic. It's not made of ions. It is a covalent compound. And when it is covalent, we have only nonmetals. So all of these different things, atoms, molecules, ions, formula units, those are all different types of what? Particles. These are all particles. A particle is usually just defined as the smallest bit of matter that is still what it is, right? Like if you took water and you broke it apart, it would no longer be a water molecule. You would have oxygen atoms and hydrogen atoms. So yeah, one water molecule is a molecule, but if you take it apart, it becomes 3 different atoms, 2 hydrogen atoms and 1 oxygen atom, and those are all particles. All right, so atoms can be neutral. They're the smallest component of an element. They can be metals or nonmetals, and you see we have the nonmetals are shaded there for us in case you have forgotten. All right. And we have specifically pointed out the noble gases, which are this column here, because we're going to be talking about those in a moment. Those are our noble gases. And you'll notice I haven't made any mention of metalloids. I've sort of ignored the fact that they exist. So we'll talk about those in Unit 3, which is coming up right shortly. In fact, during the break. Okay. But right now, we have our metals. Don't forget that hydrogen is a nonmetal, even though it's on the left-hand side. So they're pretty easy to remember because they're on the right-hand side of the staircase, except for hydrogen, which is sort of off by itself. So atoms can be any type of element, metal or nonmetal, but they are neutral. Your metals, this is what they look like when you find them in nature. What state do you think most metals are? Solid, liquid, or gas? Tell your partner. Metals. Think about some metals that you know. Are they usually solid, liquid, or gas? Silver, gold, iron, copper. At room temperature, they are solid. So what does that look like when they are a solid? It looks like this. Does this shape, does this overall arrangement remind you of any other type of matter? It looks like a ionic crystal lattice. And in fact, this is also a crystal lattice, but it's not an ionic crystal lattice. It is a metallic crystal lattice. And basically what happens is you just have all of the atoms sitting right beside each other, and they are stuck together by some bonds called metallic bonds, which we will not talk about for a long time, but you can just believe me. Something has to stick atoms together. In an ionic compound, and it's an ionic bond. In a covalent compound, it's a covalent bond, but when you have a metal and a metal, you have a metallic bond. There is an exception. Mercury is a liquid at room temperature, which you're probably familiar with. Did you guys know that? Mercury is a liquid at room temperature. But it is still those atoms, even though they can flow past one another, which is what makes it a liquid, they're still stuck together by metallic bonds. Now your nonmetals. Nonmetals are different. Some of them are gases. You guys know the symbol for gas? Super difficult. G. Okay, that doesn't look much like a G. I'm going to try that again. G, that still doesn't look like a G. Let's go, there we go, that looks like a G. Okay, so they could be gaseous. Can anyone take a look at your periodic table or one of these periodic tables that's here? Tell me a nonmetal that is a gas. Neon. Neon is a gas. In fact, guess what? All of the noble gases are shocker, they are made of gas. Okay. However, there are others that are liquid. Does anyone happen to know the one liquid? Mercury is the one liquid metal. But how about the one liquid non-metal? I wouldn't expect you to know it at this point necessarily. The one liquid non-metal at room temperature is bromine. Br2 comes as a liquid. You can feel free to write liquid like this, like with an L, a lowercase l. But I find that for myself, lowercase l's look like ones and they look like capital I's. So that's why I tend to write them like that to prevent confusion. Okay, I won't be confused by yours because I'll know what you mean, but just so you know what I'm doing, I'm just trying to keep it clear that that is an L and not a one or an I. Okay. There are other nonmetals which are solids. Once again, take a look at a periodic table, maybe those ones or the green one. Did everybody get a green periodic table, by the way? Yes? No, you did not get a green periodic table. If you did not get a green periodic table, let me know and I'll make sure you have one. I'll manage that, but anyway. All right, so on your periodic table, I would like you to look around and see if you can find a non-metal that is a solid, something that you recognize as being a solid. In fact, you could even look at this periodic table here if you don't have any that you can see. See if you can see anything that you think might be a solid. Anyone think of one or more? Carbon, yes. Where could you find carbon? If you have carbon around you, I'd like you to point to it. Anyone got some carbon? Like actually just pure carbon. Pure carbon. Elemental carbon. In the pencil lead, yes. So you all have, or at least most of you probably have, some pure carbon. The quote unquote lead of your pencil is not in fact lead at all. It's made of graphite, which is a form of carbon, and it is indeed solid. Charcoal, also made of carbon, and it is also solid. And in fact, most of these ones on the left-hand side, carbon is a solid, phosphorus is a solid, sulfur is a solid, iodine is a solid. So sort of, I mean, these ones are solids too, but they're actually metalloids. But as you get closer to the metals, you'll see that things tend to become more solid. And I don't really worry about what happens with like astatine because it is radioactive and it does not really stick around long enough. Like it decays into less radioactive stuff. So I'm not even going to worry about astatine. If I had to make a guess, I would say it is a solid. But I've never actually seen any astatine, so I don't have any evidence to that fact. It doesn't stick around long enough to really have a particular state. Okay? And then we had bromine, which was our liquid. And then all the rest are gases. And I'm really not sure about boron. I don't know what boron does when it's on its own. I'm going to guess that it is a solid. That would be my best guess. Do you need to memorize those? No, you should memorize that mercury is a liquid and that bromine is a liquid, because they're really the only two liquids. It's a little bit special. So know the two liquids. Mercury and bromine. Now, here we have, what state of matter would you guess this to be? That is a gas. It is filling its container. It's not like all at the bottom and the particles are far apart, so that's a gas. And the only types of elements that are individual atoms like that are the noble gases. So if you have a sample of helium in a box, you would have little helium atoms. Why did that not make a circle? Floating around independently of one another. Okay, on to page 94. Molecules. If you recall, we just talked about it. Molecules are neutral. They have no electrical charge. They are made of non-metals only. They are made of two or more atoms. You cannot have a molecule that is made of one atom. If you had a molecule that was only one atom, it would just be an atom, right? You just have one atom, it's not a molecule. The atoms are bonded together covalently. Do you guys remember what the word covalent means? Like a covalent bond. What do they do with their electrons in a covalent bond? They share the electrons. Okay? So just to give you a quick example of what that would look like, would someone like to be a volunteer? Anyone want to be a volunteer? Bring your pencil. Be a volunteer. Excellent, thank you. Thank you so much. Okay. Yeah, stand up, come over here, bring a pencil with you. Okay. So we have a hydrogen atom. Okay, so Isaiah is a hydrogen atom. And if you remember, hydrogen has an atomic number of 1. That means it has 1 proton. What else does it have? It's got 1 proton. How many electrons does it have? 1 electron. Okay, this is going to be reviewed over the break. If you've forgotten all that, and you're like, what just happened? I don't know. Anyway, 1 electron. I also have 1 electron. This is my electron. Hold up your electron. Okay. Now, you guys remember how many electrons make a full shell? 2, at least for that first shell, right? It's 2, and then anyone remember the second shell? 8, and then 8, and then the model postmark. But don't worry, again, that will be reviewed for you over screen right now. So I would like to have 2 electrons. Isaiah would like to have 2 electrons. So we are going to share the 2 electrons. Now I have 2 electrons, and Isaiah has 2 electrons. What charges are electrons? Remember? Electrons are negative. And here's my nucleus. What charge is the nucleus? Positive, because it contains the protons. And don't worry, this is going to be reviewed with you. I will over spring break, okay? So we have a positive nucleus there and a positive nucleus there. What does positive do to negative? Positive and negative, they balance each other out, but they also do something else. They attract. So I am pulling these electrons towards me, but Isaiah is also pulling the electrons towards him because my positive charge is pulling on the electrons and the negative charge is pulling on the electrons. And look, that's a bond. Okay, because we're both pulling on those electrons. And actually, the funny thing is that if you actually have a molecule, did you see how there was that like wibbly wobbly? Molecules actually do that. They actually vibrate. They go, right? They're not completely static. Like the 2 atoms will actually vibrate a little. Okay? So, molecules can be elements where you have only one type. That was like that hydrogen atom, yes? So maybe we have a hydrogen atom bonded to another hydrogen atom. That is a molecule of an element. But there's only one type of atom, so it's just still an element, but it's a molecule of an element. What if you have 2 or more types of atoms? What do you have? 2 or more types of atoms gives you a compound. See if you can give an example of a covalent compound to your partner. And yes, you're welcome to use the most obvious one, but you're welcome to use any of them. So if we have 2 or more types of atoms, what could an example be? CO2 could be an example, right? We could have a carbon and we could have an oxygen and we could have an oxygen. That would be a molecule of a compound. And in fact, at the bottom of the page, we have tons of examples here. You'll notice we have iodine. When iodine exists in nature, let's zoom in on that. It's not just a single I atom, it's I bonded by a covalent bond. There's our covalent bond right there. That is a pair of shared electrons. Okay, so we can imagine that there's a couple of electrons there that are being shared. And so when we write its formula, we don't just write I, we write I with a little, what's that little number at the bottom called? Do you remember? It's called a subscript. And what does the subscript tell you? The number of atoms of that type, okay? So, because it's beside the I, that means we have two I's. Phosphorus, one of the forms it comes in is actually like this little pyramid kind of thing. Okay, it's kind of cool. And it's made of 4 phosphoruses, so we use the subscript 4 to indicate that we have 4 phosphorus atoms in a phosphorus molecule. And then sulfur does something even more fun. It makes almost like a little crown structure. Okay, and we often represent sulfur with the color yellow. Anyone know why? You ever seen the sulfur piles down in Port Moody? No? Oh, yeah, have you seen them? Yeah, big, huge piles, and they're yellow. And if the wind's blowing the wrong way, it smells kind of funky. Okay, so sulfur is actually a nice, lovely yellow color, pretty much exactly what you see there. But one of the forms sulfur takes is S8. It's made of 8 sulfur atoms bonded together. So there we go. And then we have O2. What do you think it means that we have 2 lines here? Compare that with iodine, which just had a single line. Iodine was down there and it was sharing 2 electrons, 1 pair of shared electrons. What do you think's happening down here with oxygen and its 2 lines? 2 pairs of shared electrons. So we would have 1, 2, 3, 4. And we call that a double bond. Have you heard of a double bond before? I don't know if you do that in grade 10 at all. Yeah? At least some of you have. And if you only have 1 pair of shared electrons, that is called a single bond. Oops. Now, elements are pretty boring when it comes to their molecules. They're mostly like 2. There's O2, Cl2, I2, Br2, N2, F2, H2. Most of them contain 2 atoms. Only a few of them, like phosphorus, is P4 and sulfur is S8. But when you get into molecules of compounds, things can get pretty fancy pretty quickly. We have a simple one like water, H2O. We have something more complicated like CH4. Does anyone know what CH4 is called? Probably not, I'm guessing. CH4 is called methane. And it's the gas that comes out of these gas pipes, and so it's what burns when we light the Bunsen burner. The prefix meth means 1 carbon. So you might have methanol, which is an alcohol that contains 1 carbon. You might have methanal, which is an aldehyde that contains 1 carbon. But we'll worry about that later. Okay, but yeah, you can get things that are really quite funky. I think this thing here, which literally, if you look at, oh my gosh, the formula's wrong. That should be an N4. Because if you look, there's 4 N's. Just a note for me, fix this. I believe this is caffeine. Okay, so that is what will perk you up if you have a cup of coffee, or it'll make you jittery if you don't respond to caffeine well. Okay. But all of these models that you see here, they're all made of little balls attached by sticks. Okay, the balls represent the atoms and the sticks represent the covalent bonds, the shared electrons. And so guess what we call them? We call them ball and stick models because they're made of balls and sticks. Ball and stick models. There is another way of showing them, which is probably more accurate. And it just sort of shows that the atoms really, there's no actual like stick for the bond. They're just sort of like overlapping one another. And those are called space filling models. Okay, and you can see O2, there's no longer 2 sticks in between. It's just sort of one blob overlapping another blob. Okay. These are more accurate, but it's also harder to do things like count the number of atoms, especially if you're dealing with something really complicated like caffeine. I should grab a space filling model of caffeine, and it becomes really hard to see what's where. Okay. And that takes us to ions, and I feel like that would be a good place to stop. Okay. And there is no homework associated with this, your homework, but do bring this book with you and your atoms book when you come back from break. Your homework for the break is in the homework section now, as well as on the general channel. Do you have to do it? Well, if you want credit for it, you do. It will go in as a lab assignment mark, okay? If you don't know something, should you copy it from the answer key? No, you should put a question mark beside it and ask about it when you get back, okay? Oh, thank you. If you guys want another grade before, like on the test before you leave for spring break, just drop by tomorrow. I should have it for you, okay? Yeah. Although I have yours already. Dayoon. Oh, I don't have yours. I have Jilly's. Sorry. It was out of 20. 19.25 out of 20, and then 6 out of 6 for the enriched stuff. Okay. Hey.
I'm going to ask you if you need help too.
Oh, I could. Yeah. Yeah, sure.